Hello everyone, welcome back to Jeff Geo Academy YouTube channel. So in this lecture we are dealing with some of the numerical of the concept of isostasy. So let's start our talk. So you already know the formula of different model. Here I have written Airys model formula, Airys model, which is R will be equal to H rho C divided by rho m minus rho c. Now here R is the thickness of mountain, H is the height of mountain above mean sea level, rho c is the density of crust, rho m is the density of mantle, and rho c is the density of crust. So if you don't know how this formula is derived, I am not going into it. So if you have any doubt regarding how the formula is derived, and you go through the book William Lowry, or you may follow Lilly for the derivation of this formula. But in the GATE exam, no one is going to ask you derive this formula. They will ask the GATE will ask the numerical from this formula. So if you want me to derive this formula, then comment me, I will derive this formula also. Okay, so let's start directly with the numerical problems. So here is a question for you. For Airys isostatic compensated mountain having elevation of 2 km with density 2.7 gram per cc, which is equilibrium with mantle having density 3.3 gram per cc. So this is the data he has given. 2 km mountain having 2 km elevation with a density. This is the another data he has given, and this is the density of mantle is another data he has given, and he is asking about the root. What will be the root? So look, here I have draw diagram for this numerical. So if this is our mountain, and this is the depth of compensation, and the height is 2 km, the height is 2 km, sorry, the elevation is 2 km, and now he is asking about this height. This height he has given, and he is asking us what will be the height of what will be the root of this mountain. So this is the root of the mountain, so let this root be r1. Okay, now here the data he has given, I have written here h1 is equal to 2 km, density of mantle will be equal to 3.3 gram per cc, density of crust will be equal to 2.7 gram per cc. Okay, so these three data he has given, these three data, this one and this one data I have written here. Now for Airys isostatic, for Airys model of isostasy, h1 height h1 will be equal to rho r1 bracket rho m minus rho c divided by rho c. Okay, now we have to calculate r1, we have to calculate this height, we have to calculate this height. So I have r1, I have I make this r1 to left side. Okay, so now r1 will be equal to rho h1, r1 will be equal to h1 multiply rho c, cross multiplication, and divided by rm minus rho m minus rho c. Now just put the value of h1, put the value of rho c, this is rho c, put the value of rho m, this is rho m, put the value of rho c, this is rho c. Now on putting all the values, we finally got the answer 9 km. So this height will be 9 km. So if the mountain is elevated having height 2 km, then in the depth it has 9 km. Okay, so our answer will be 9 km. This is the answer. Okay, now let's move on to the next numerical. Now here I have written a question which is a JAM 2019 question. So in this question he has given in the diagram, he has given a diagram. A 6 kilometer height plateau is supported by a crustal root of thickness R. So the thickness of root is R. The system is in isostatic equilibrium as per Airys hypothesis. So here we have to put the formula of Airys model of isostatic density of crust and mantle are 2800 kg per meter cube and 31,000 kg per meter cube respectively. So assuming G to be the same throughout the region, the thickness of root R is, so he is asking about the thickness of the root. Okay, so he has given us height 6 kilometer and asking about the thickness. Okay, thickness of the root he is asking. Now look here what data he has given. So this data, height is given, and the density of crust is given, and the density of mantle is also given. This is the density of mantle and this is the density of crust. Okay, now we are going to solve this problem. So now I have mentioned wrongly, the density of crust is 2800 km and density of mantle is 3100 km per meter cube. Okay, now here the height h1 is 6 km and this one is 10 km, and the density of mantle is a 3100 km and density of crust is 2100 km, and he is asking about this height, this much height from here to here, what will be the this height he is asking us. Okay, now this is the depth of compensation, this is the depth of compensation. Now we know the formula from Airy isostasy model, h1 will be equal to r1 rho m minus rho c divided by rho c. Now we have to calculate r1, we have to calculate this height, this depth, this root, this is the root r1. So here r1 will be equal to, by cross multiplication, r1 will be equal to h1 rho c divided by rho m minus rho c. Now just put the value of h1, this is h1, put the value of h1, put the value of rho c, this is rho c, and put the value of rho m, this is the rho m, and put the value of rho c, this is the rho c. This is just for confusing us. Okay, 10 km. Now by putting the value we got the root r1 will be equal to 56 km. This is the answer. Okay, so root r1 will be equal to 56 km. Now take a screenshot. So so don't confuse in the numerical, it is very easy, and you will enjoy in solving the numericals. So stay tuned with the channel. This is the end of the lecture. In the next lecture we will deal with different numericals. Okay, so thank you for your patience, and if you have not joined our Telegram channel, we have also a Telegram channel. I have given link in the description box. You can join our Telegram channel also, and I have given many quiz there, so you can solve those quiz and related to the topic. So thank you for your patience.